Okay, so we have this next question right here. It says the photograph shows a floating object called a buoy. A long chain attaches the buoy to a very large mass at the bottom of the sea so that the buoy remains stationary. The water flow past the buoy causes a horizontal force 260 Newton on the buoy. The chain exerts a force F on the buoy at an angle of 33° to the vertical as shown. Okay, show that the F is about 500 newtons. So it's very simple. First step is to draw your vector diagram, right? So here is our resultant line, which is your F line. This is your resultant line. And in order to draw a vector diagram, right, we have to reach here. Okay, remember that we have to reach at this red point. So you can only use up, down, left, right. So first you will go down and then you will go left side. Okay, so this is causing a 90-degree angle. Overall it's a right angle triangle, and this is your angle 33° here. Opposite to this angle is always sine theta, and the line which is not a resultant line or a sine theta line, it is a cos theta line. Okay, sorry, and then theta line. Okay, so now this is your first step done. Now your second step is analyze what values you can work with to get this F, right? So I can see that I can't use my vertical component, right? Because it is not actually, there's no other value except cos theta. So we can't use the vertical components, but we can use the horizontal components. If you can see that your left side, right, your left arrow contains F sine theta and your right arrow contains 260 newtons, right? This right here and this right here. So we can use this at our advantage and get the value of F. So F sine theta will be equal to 260 Newton. Okay. You can also write it F sine theta minus 260 Newton, but then you have to figure out what direction of motion you want to take. Like for example, if you want to take right side as positive, then your F sine theta will be negative and your 260 will be positive. If you want to take left side as positive, so you will have this thing right here which is like F sine theta as positive, and you have negative 260, which is now equal to 0 as well. You can write it this as this like this as well, but it is completely up to you. I prefer this way because then I have to not select the direction of motion. So now F sine theta is 33-degree angle and you have 260 newtons. Now if you shift the sine theta downwards, right, because it's multiplying with F, so it will divide on the right side, so it's 260 by sine 33, and your value will be, your answer will be 477 newtons. If you round it off to two significant figures, it will be 480 newtons, right? Why two significant figures? Because I can see that there are like two values, and even this value is in two significant figures. So just write your answer in two significant figures as well. Okay, so we have this next part right here. It says the buoy floats due to the upthrust from the water. The weight of the water displaced by the buoy is 2.9 k newtons. K is times 10 to the power 3 newtons. Determine the weight of the buoy. Okay, so it's a very simple question. We will use the diagram. I will explain you through diagram. So this is our buoy, and you have weight acting downwards and of course upthrust acting upwards, and you have one more force which is acting diagonally, like type of diagonally at 33-degree angle, which is this one. I have drawn the vector diagram here from the previous part, and this is your F force, right, which we found from the previous part, which was 477 Newton, right? Now you can see from the components as well that you have upthrust acting upwards and you have force and weight acting downwards, right? So force has a component cos, so we have F cos theta plus the weight, right? You can't directly use F, you have to use one of its components, right? So f cos theta is acting downwards. Now, if you solve this, you will get the weight of the boy, right? So you have u, which is here, which is 2.9 times 10 raised to power 3 is equals to f is 477 cos you have theta as 33 degree plus you need to find weight. Okay, so if you subtract these values, you will get your final answer as 2500 newtons. Okay, so we have this next part here. It says the speed of the water flowing past the buoy increases, so the horizontal force increases. Assume that the weight of the water displaced by the buoy doesn't change. Explain how f and theta change when the horizontal force increases. So it's simple, right? First, make sure you have drawn your vector diagram, right? So this is your resultant line, and then you go down and left 90 degree, and this is your theta here. Okay, now what happened is that your horizontal force is increasing, right? So in order to balance it, or in order to make it stationary, it was mentioned in the part A that the buoy is stationary, right? To in order to, right, keep the status of stationary, the f sine theta, which was here, and f cos theta, right? F sine theta here has to be increasing as well at the same time, right? So we have to just simply write this over here. But remember that f cos theta doesn't change because they assume that the weight of the water displaced by the buoy doesn't change. It means that the vertical component has not been affected at all right now. Okay, so now first we will write about our horizontal component, right? So horizontal component of the force, basically F, increases to maintain the status of equilibrium. Okay, and how will it maintain it? We have to explain it using the formula. So we can explain it using Pythagoras theorem, which is a square plus b square is equal to c square. I know you might have heard about it. So let me draw the diagram. So this is your resultant force F here, down and left 90 degree, and theta here. So this is your FH horizontal component, and this is our FV vertical component, right? So you will write F square, right? This is your C. You can consider A or B this, or B A this. You can change A B, but don't change C. C is always the opposite to hypotenuse. This is your hypotenuse, opposite to this. So F square, sorry, equals to FV square plus FH square. Okay. So if FH is increasing, so if FH increases, then the F value increases, right? So we have to just say that. And the second thing we have to say that we can also, there's a second way as well, we can also explain it through the theta matter, right? Sine cos theta, right? So in order to explain it through sine cos theta, let me draw it again, the diagram. So you have F here, this right angle theta, and you can use the same thing again, FH FV vertical horizontal component. Now you can use the tan theta formula, which is opposite over hypotenuse, sorry, opposite over base. Tan theta is opposite over base, so opposite is FH by FV. So if your FV is increasing, sorry, not your FV, so your FH is increasing, then your angle will also increase, even if you just shift this tan to the right side, which will make it theta is equals to tan inverse of fh by fp, right? So even if your fh is increasing in this position, your theta will always increase, right? So you can just write the same formula here instead of this. Either ways, both will be correct. And if you decide to write one of them, then just explain that your f basically yeah. So f cos theta, because I haven't mentioned about our vertical component, so I can just say f cos theta, or the vertical component is constant, right? I forgot to mention that. You need to mention that as well. F cos theta is constant. So uh increase, right? I mentioned that. Now you can say, so increase in either the f or the theta value. Either ways, if you increase one of them, the other person will follow it. Like if you increase f, theta will follow it. Okay, implies an increase, right? In let me write in another line, in the other.